Welcome to my lecture on moment generating functions and transformations. Um, okay. In this example, I'm going to let x1 be a Poisson distribution, and its parameter or mean is going to be k equals 2. x2 is Poisson with k equal to 3, and x sub 3 is also Poisson with k equal to 7. Now, I'm going to additionally assume each xi is independent. Okay. Now, what we're going to be asked to determine is to determine the distribution of y equal to x1 plus x2 plus x3. Okay. Now, because of the independence assumption, we can go ahead and use theorem 7.3.2. And that says that the moment generating function of y is the moment generating function of x1 of t times the moment generating function of x2 of t times the moment generating function of x3 of t. Okay. And by page 78, we know each of these moment generating functions. So the Poisson distribution, okay, has a moment generating function given by e to the k times e to the t minus 1. And I'll write that down. Okay. So right over here, I'll just do page 78. Moment generating function of a Poisson has this form e to the k times e to the t minus 1. Okay. So for the first one, we know that k is 2. So this is going to be e to the 2 times e to the t minus 1 times the moment generating function of x2. So this will be e to the 3 times e to the t minus 1. And here I'm specifying the value of k in each of these. Okay, times the moment generating function of x3, which is 7 times e to the t minus 1. And just by using algebra, I can combine all these. They add. So I'm going to get e. They all have the same thing that they're being multiplied by, namely this e to the t minus 1 is common in all of them. So when I add them, I'm going to get 2 plus 3 plus 7 is going to be 12 times e to the t minus 1. Okay. And this, so by theorem 7.3.1, this is the moment generating function right here. It has this same form of this box right here. Y has, so by theorem 7.3.1, since it has the moment generating function of a Poisson distribution, Y, the random variable Y, is a Poisson distribution. Y has a Poisson distribution with parameter k. Okay, and it's very important to specify the parameter. Okay, so that was an example using theorem 7.3.1 and 7.3.2 to determine the distribution of a sum of random variables. All right, thank you for watching.